Good morning. Today we're going to start section 4.4, which is evaluate logarithms and graph logarithmic functions. We're going to actually do this whole section today because section 4.5 I want to spend some more time on. So let's get into what a logarithm is. I really like this graphic better than the one the book had. A logarithm is just another way of writing exponents. So we've been working with exponents in this chapter. So if you consider this logarithmic form, it says log base b of a equals x. So let's think about what all those mean. It's nice to use the base b right here because this is our base, and x is our exponent. That's how I always remember this. So when you write this in exponential form, what this will look like is your base, which is b, raised to your exponent, and then the only thing that's left is equals a. So that's just how you're going to flip between writing these. So that's one of the skills we're going to practice. The book uses y instead of a. But this is that definition there, and it just says that b can't equal 1. And the reason for that is because everything would be 1. So the first skill here is to rewrite logarithmic or exponential equations as each other. So if we look at a, these are in logarithmic form. So again, this is my base, and it equals my exponent. So I start with my base 2 of 3 equals 8. And notice that makes sense too, right? If you were to solve this, 2 to the third equals 8. You wouldn't say 2 to the 8 equals 3 because that doesn't make any sense. Same thing for b. Start with my base, and then 4 raised to the 0 has to equal 1. All right, c and d are going the other way. I want to write this as a logarithm. So I start with log, and then I look at this is my base, this is my exponent. So it'll be log base 12. Notice the 12 kind of sinks down. The exponent needs to go after the equal sign, which means that the other 12 needs to be right there. For d, it doesn't matter that it's a fraction. This is still totally, you can do this. Log base the fraction, so 1 over 4, of this outside part, 4, equals negative 1. Just to note, anytime you see something with a fraction, negative 1 is going to be in there somewhere. A negative number. So to evaluate logarithms, sorry, this wrote this twice for whatever reason. Just erase that. Your calculator can do it, but it's a bit of a pain. So let's just talk about how to do these on our own. So 4 raised to what power equals 64? 4 to the first is 4. 4 to the second is 16. 4 to the third, I believe is 64, right? It shouldn't be too big. Double check that here. 4 to the third be 16 times 4, which is 64. So that means that this equals 3. This one, 6 to what power equals 36? Well, hopefully you have your squares memorized because squares are good. So it's 6 to the second power equals 36, which means that this equals 2. This one's a little trickier. 1/5 to what power equals 125? All right, remember I said anytime there's a fraction involved, you know you're going to have a negative part, okay? Now, if I had 5 to some power equals 125, that's a little easier, right? Because that'd be 5 to the third power. So that means if it's a fraction, this must be a negative 3. So let's talk about your calculator and what logs look like on that. So we have some special logarithms. Actually, the original logarithm was base e, I believe. I posted a video of the history of logs if you're interested, because they are kind of random, but they're very useful. Or they were before calculators. Now they're a little less useful. But a common logarithm is a logarithm with base 10. It is denoted by log base 10 or simply by log. So if you ever see one where there's no base, that is log base 10. And that's what our calculator has readily on hand. So you have to be careful when you use it, because it's not true that log base 10 of 64 is the same as log base 4 of 64, for example. So we have to be a little careful there. Then we also have a natural logarithm. Natural logarithm, and maybe you can guess. But this is a logarithm with base e. It can be denoted as log base e, which I have never seen. It's more often denoted by ln. Okay. So again, common logarithm is log base 10, which is equal to just the log. And the natural logarithm is log base e, which is way more written as ln, or natural log. So then let's talk about graphing these. I want to remind you, logarithms are the inverse function for an exponent. And remember, when we were talking about inverse functions, we had this rule where they were a reflection over this dotted xy line. So your logarithm, if your exponential graph is this blue one right here, your logarithm is this red one. And there are a couple key points to consider. You always want to consider when x is equal to 1 and when x is equal to whatever your base is. Okay, those are two key points, because then you really wouldn't even necessarily need a table of values. I'll show you how to do both, but that's kind of my trick for graphing these. So we have two functions to graph. The first one is y equals log base 3 of x. This right here, I've already graphed 3 to the x, just because I want to see you that, or show you that this is truly a reflection over this line right here. Okay, so we can make a table with this. We can also consider those points that I talked about. So I want to consider those points first. What if x is equal to 1? And what if x is equal to our base, which in this case is 3? Well, if x was equal to 1, so I can put 1 right here, that means whatever we get is equal to y. So that would give us log base 3 of 1 equals what power? If we consider that as an exponent, that's the same as saying 3 to what power equals 1. Well, this is the one where it's always 0, right? 3 to the 0 power equals 1. Anytime you raise to 0, you get 1. So that would give our y a 0. And then on the flip side, if we consider log base 3 of 3 equals something, well, as an exponent, that would be 3 to what power equals itself. And hopefully you know that that's 3 to the first power equals itself. So if x equals 3, y equals 1. So with just those 2 points, and knowing that it's going to be a reflection, a curve of this line right here, I can graph those. I go to x equals 1, y equals 0. That'd be right here. And then I can go to x equals 3, and y equals 1, which is right here. And again, it's going to be a curve of that other line. So it'll look like something like this. And hopefully you can see that that's a reflection. So that goes down a bit. And that's all there is to it, really. So this wants the domain and range too. It's really easy for you guys. Domain is all real numbers. Range, all real numbers. All right, let's consider part B now. Again, I want to think about where my x is equal to 1 and where my x is equal to the base, which in this case is 1/2. So we'll start with x equals 1/2 and x equals 1. So if x was 1, log to the 1/2 of 1 equals what? Well, this is the same as 1/2 to what power equals 1? Well, it's still going to be 0. If x is 1/2, that means that log to base 1/2 of 1/2 equals what? Well, that's the same as having 1/2 to what power equals 1/2? Well, that's going to be 1. So for this one, when you graph it, x at 1/2 is right here, y is at 1, so that's here. and then x at 1, y at 0. That would be right there. Okay, this one is harder to see. I'm like, okay, I don't really know what a reflection looks like there. So let's go ahead and look at this right here. Okay, this is why I don't love doing it on a calculator. So I want you guys to see this log button here. This is base 10. Don't use that unless you're in base 10. Same thing with this one, ln, that's base e. Those are the two that you have readily at hand. If we want to graph a base other than 10 or e, we have to go to our math menu. You have to scroll down, and then you see where it says a log base. That's what you're going to hit. It looks different on different calculators is the issue, and I don't have a way to show you with the old calculators. But you can also use Desmos if you need to. So our base is 1/2 of x. If I want to look at the table, notice there's an error at 0. There's an error at a bunch of these actually. So here, at 2 we're at -1, at 1 we're at 0 like we said. It doesn't show the half, but we're there too. So let's pick up some other points that we can graph easily. So at 2 we're at -1, at 4 we're at -2. So at 2 we're at -1, and at 4 we're at -2, right? Just double check that, yeah. So if I graph those, at 2 we're at -1, at 4 we're at -2. I don't think that other one's graphed correctly, actually. So here our domain is not all real numbers. Actually, I'm not sure our domain is all real numbers for part A too. Let me check that. You can see it in the graph though. It stops at 0, right? X can't be 0. So we can say x greater than 0. And then our range is all real numbers. I think the same is true actually here. X can't be 0. X greater than 0. Because it can't be negative. That makes sense. So, sorry about that. Your domain will always be x greater than 0 unless it's shifted in some way, but I think on the worksheet you're good to go. So that's how we're going to graph these. I highly recommend Desmos for graphing these, just because it's one thing I really don't like on our calculators. But you can use your calculator to graph these. Remember, if you have any questions, I have office hours tomorrow, Wednesday, and Thursday. And you can always email me.